In this video, we're going to conclude our discussions regarding the transition from basic math to algebra by looking at two important yet subtle points regarding that transition, if you will. And we'll start with this by reminding ourselves that, again, in basic math, we're dealing basically with the operations, your fundamental operations, your basic operations. Operations, we mean adding, subtracting, multiplying, and dividing whole numbers. Well, not whole numbers, but we should say all the numbers that can be generated, all the real numbers that can be represented by the real number line, depicted by the numbers on the real number line. Okay, so real numbers are usually depicted with a number line, and these real numbers are varied, but these are the values that we add, multiply, subtract, and divide. Okay, and we remind ourselves again also that when in basic math, the nice thing about it is that the instructors usually give us the problems to do, whether it's 4 plus 6, or it could be 3.5 times 1.5 or something. Let's go back and clean that up a little bit. Let's go times 3/5, and finally it could be something we may have to find 5% of 80 or something. Okay, and all of these problems involve certain operations: addition, multiplication, and this would also be a multiplication. You'd have to know how to change it to from a percent to a decimal. But all of those are basic math skills that you've mastered now before you begin to entertain doing the algebra. All right. And again, and as we repeat, in algebra, we're going to continue to add and subtract, multiply, and divide. That hasn't changed. The only thing that has changed is, and we're going to do this, of course, with real numbers. The thing that we want to consider is that rather than giving us explicit values, you're going to get algebraic expressions. Something, instead of 4 plus 6, they may give you 4 plus x. Okay, and therefore, but instead of a problem like this, if it's multiplication, they may give you we may be given let's go with x times y, and that would be a product. And finally, this would also be a product. We'd have 5%. You can have 0.05, 5% of 80, of 5% of p. Okay, some variable. So really quickly, we have the addition operation. Now here's one of the first subtle points we want to point out. Rather than giving you the time symbol this way, we normally in algebra, of course, we just put the variables right next to each other. There may be times you put a dot there, but obviously we do not want to confuse this time symbols with the variable x. So the first subtle point, in algebra, we usually do not use x 4 times as we do in basic math. Okay. Similarly here, we need to know, of course, that these guys are right next to each other. So again, they're being multiplied. Another one, just so since we're indicating or looking at these subtle points, if we were to give something like 14 divided by 3, if that's the problem, the basic math problem that you're to do, when you write that as an algebraic expression, or you write division problems in general as algebraic expressions, most times, more often than not, we use the fraction bar. So you'd have something like r over s. That would be a division problem. So we don't usually use the time symbol, nor is it usual that you use division. You can, but very rarely do we use the division symbol of this sort. Usually in algebra, your division problems are written as fractions. So two subtle points to be had. All right. Now the other thing we want to recognize is that these guys in algebra are referred to as expressions. These are algebraic expressions. expressions. And as such, we already talked about the fact that these expressions, what are expressions? Now this may seem like a reverse way of approaching it, but in covering the concept of what an algebraic expression is, we would prefer to kind of look at what algebraic expressions are not. So let's to really drive the point home, let's look at the general topic of expressions. And we've made the point that math is a language, so we're going to look at it in the context of comparing English expressions. We have expressions in English, of course, and to our algebra expressions, and how that term is, how its similarities and their differences, how it compares and contrasts in the two disciplines, if you will. All right. Now, for English, if we have an expression, an English expression would be something like shut the door. Shut the door. That would be an expression. You can say open it. Open it would be an expression, an English expression. Let's do one last one. Let's say turn it on. So these would be 1, 2, 3 English expressions. So that's how expressions are put forth in English. Now, in algebra, we've already talked about the fact that algebraic expressions, let's go back, something like a 3m would be an algebraic expression. We use this one a few times in other videos. We have x plus y would be an expression, and let's finally let's start with an. How about we end it with an r over s? We had that one in the examples above. Okay, so these would be algebraic expressions. Now, as I said, what we're going to do is we're going to tell what these guys are, essentially by beginning by saying what they're not. And I think that would be the most powerful way of making the point. In English, what English expressions are not, and what they are not, they're not complete sentences. Complete sentences. So English expressions are not complete sentences in that they don't adhere to the rules that govern having a complete sentence, if you will. So they do communicate ideas, they do communicate information, but not as a formal complete sentence. Similarly, in algebra, we're going to define algebraic expressions more powerfully by what they're not. And what they are not, they're not equations. So an algebraic expression is not an equation. They're not equations. All right. So now, why are they not equations? Well, besides the obvious, they do not have equal signs. All right. So they're not equations. They do not have equal signs, and for that reason, we cannot solve them. You do not solve algebraic expressions. Okay. They cannot be solved. What you can do with them is you can evaluate them. So you will be asked as homework problems or exercises to evaluate an expression. So you can evaluate them. So, and here's the difference. What's again the subtle difference? In order to evaluate the expression, again, remember now that these expressions are these variables, we should say, are take on various values, and those values are generated from the number line. Okay, so all the real numbers, you have your 0, positive, negative integers, fractions, decimals, percent, any number from the real number line, any number from our real number system can be used to represent one of these variables. But in order to evaluate it, obviously, the variables must be assigned values. They must be assigned. You need to know what this number is. And so we will have here m, x, y, r's, and s's. So let's go ahead and take a look at how that would work. You would have to be told that the real number m is, let's go with a 2 or something. You would have to be told that x is let's go with perhaps a negative 0.5. Negative. Let's back that up. Let's make it x is a negative 0.5. Y could be a fraction. It could be 3/5. And finally, you would need to know that S is equal to it. Let's say S is 3%. You really don't know what type of real number it is, but it could be an integer, it could be a decimal, it could be a fraction, it could be a percent. Those are the values that you're asked to evaluate. Now, so to evaluate the expression, of course, what we would do is we would take these expressions, and we'll just go ahead and copy these guys here, and just copy them, and so that we can use these same expressions and evaluate them. We'll just place them here, and that would do just fine. We're going to take a look, and we're going to evaluate these expressions given this information. Okay, so in this case, we know now that let's see, m is 2, so we'll go back here and make that replacement. This would become 3 times 2, and therefore when we evaluate this first expression, the first one here, that evaluates to be 6. Alright, so that expression is a 6. When we go to the second one, we have x plus y. We know that x is, what is x? 0.5, a negative 0.5. We'd put that there, substitute and replace that, and then we're going to add that to a 3/5. So this is 3/5. We'll go ahead and change the color so we can not lose track of what we're doing here. This is a negative 0.5, negative 0.5, okay, 0.5, and here's where your basic math skills come into play. This is 3/5, which is of course 0.6. That's 0.6, 6/10, so that's plus a 0.6. And so when we combine these guys, add those together, we'll end up with a 0.1 as our value, our answer there. Okay, so that was equal to a 0.1. And finally, that's the second one. That was expression number 2. We've evaluated that, and let's go ahead and do expression number 3. We'll go ahead and do this one going in a vertical direction here. We know that r is, we didn't assign r. Alright, so r is still unknown. And so let's define. We'll work with that. We'll leave r as an unknown value. We don't have that information, and I provided we could do it now, but that's neither here nor there. But we do know that s is 3%, so we are going to put our 3% there. And more often than not, we do not like to have fractions and decimals and fractions and percents mixed in, so we're going to go back to our basic math skills and make this 3% a 0.03, 0.03. And also what you might want to remember is that this is really division, so this is r divided by 0.03, which is, let's make that 300ths. We'll read that properly, and we'll do some additional videos on this. We know that to divide a fraction is the same as multiplying. Notice our new multiplication symbol there by the reciprocal. And so finally our expression, this expression, we didn't know what r was, so we'll just have to leave it as 100 r over 3, and we'll leave it there. Alright, so to conclude, the main point, two crucial points in this presentation, not the least of which the first was that we want to recognize that to make the transition from basic math to algebra complete, we're going to have to make an adjustment in our notations. Okay, we don't use the time symbol anymore. We won't, it's not banned, but we rarely use it in algebra so as not to be confused with x. So that was point number 1. And the second point that we want to know is that when we talk about expressions, the most important thing to realize is that we cannot solve expressions. The best we can do, or you'll be asked to do, is to evaluate expressions. Alright? 2 subtle points, but important points, and we believe strongly that if you keep these things in mind, that your transition from basic math to algebra will be complete. All right. Thanks for visiting, and we'll see you in the next video.